This is exciting.
Have a seat.
Yes. So my slides are going here as entertaining as dates, so I'll try to be entertaining. Probably not so much. Anyway, chicken data capture. This is the thing.
Yay!
Josh,
Yeah,
Hess is laughing.
Should we not finish the room?
Yes.
Josh, we need you to stand up here so the mic can pick you up.
I figure I'm loud enough that it'll get me, but
No, it's unidirectional.
I can
That
change
makes
the
sense.
parameters of the microphone.
No, it's good. So I call this a study in compromise. That's probably true of any major feature in Cassandra, but this one it had that special flavor to it. So the axes of compromise that I kind of want to go over here is what we want versus what Cassandra wants. And the rest you can read, you're all literate. But basically, these are kind of the classic things you have to compromise on when designing in any kind of environment, but most especially in a distributed environment and one where we kind of want things to stay fast. And then I'll talk a little bit about the road forward. Like, what does it look like? What else are we going to put in tree? What are our goals for this feature? So what we want, you can see the JIRA ticket 8844, and this is kind of the gist of it. But largely it is like people shouldn't have to ETL data out of Cassandra periodically. People shouldn't have to like home roll their own ghetto hack system to try to get stuff out of Cassandra into whatever kind of systems they're trying to get it into, or to display things in a front end system, et cetera. Like there's, right now, like you have to pull Cassandra and pull data out, or you have to do that ETL. You've got, basically everybody has to roll their own. Right? And so the idea is, what can we write so people don't have to roll their own anymore, or at least extend a little bit further along that path so some of the more painful base parts of this infrastructure people have to do themselves. I put in bold two things that I'm going to talk a little bit more about on the next slide that are problematic for us, to say the least. So delivering exactly once, obviously kind of hard, multiple replicas, and semi-real time. Well, you know, not possible is one way to phrase it. And then the question of whether or not we're going to make this thing semi-real time. If we can, if we do, what that looks like. And spoiler alert is in V1 node. And V2, we're going to give people the tools to do that if they see fit to tackle that piece. So what we want and what Cassandra wants aren't the same. When this ticket was opened, there was a lot of thought that had gone into it. There was a lot of design. There was like, maybe we can do it this way. Here's a couple of alternative approaches. And you could tell that a lot of TLC had gone into this. And so I ended up having to be the guy that basically had to go shit on somebody else's dreams, for lack of a more delicate way to phrase it, where it's like, if you want this written to two separate log files, for instance, we have a fundamental problem. And this is something that we bashed our head against and chewed on for a while.
So do you want to back up and give an overview of what the proposal was?
That we talk about.
You have 20 minutes.
15. 15. So the proposal itself is pretty much right here, right? I mean, I can talk about it, right? So
you're jumping into like the two files problem, and so does everyone in the room understand what the two files are?
Sure. No.
Okay, so just to clarify, the original proposal was, and I was going to talk about that.
Okay, sorry.
Yeah.
Hey, I would love to see like a diagram of like. I was like, there's a lot of good ideas on that ticket, and so you do like draw out what the going to do.
Yeah, that'd probably be a good discussion for tomorrow, and later on I do have a diagram for what's going on with it.
It's a short enough ticket, just read it.
Yeah! So I can explain it pretty simply. So the idea was, you get data into Cassandra, you write it to a commit log, and then you write separate data to another log file that's your CDC log. So if you've enabled CDC for a table, you write to the commit log, you write to the separate file. And that separate file is your CDC log, and everything's great. There was a lot of debate and discussion of, do we want to store this stuff in memory and feed it out over a socket? Do we want to make this thing available via CQL for ingestion? Do we want people to be able to hook UDFs into it to actually transform it? There was all kinds of stuff flying around, right? And the problem that we run into is at the end of the day, something as simple as write to a commit log and write to a separate CDC log fundamentally breaks the ability to have a contract to say, yes, if it's in the commit log, CDC is going to get it. And the problem with that was kind of a pretty subtle, nasty one, where if you write to the commit log, but then the CDC allocation fails because it's on a spindle or you fill up your drive, all of a sudden we have to look at a mechanism of how do we pull the data back out of the commit log, right? Or I'm gonna get an allocation object into both, I'm gonna try to write to both, but then the node goes down. There's this tiny little race window, which made it super, super difficult to actually be able to say, yes, if you have data in one file on disk, we can guarantee that you have it in another. So like the atomicity of two F-syncs, not a pretty thing to try to solve. So another issue that we're looking at with that is what happens if you have a certain buffer in memory of the CDC data, but you have a slow consumer that picks up that CDC data once every 3 months, for instance. Well, then you got a boatload of memory that's just sitting there that nobody's reading, that nobody's consuming, that's getting promoted, and then your old gen stop the world collections. Like there's just all these ramifications to shoving all this stuff into Cassandra proper. And so me working on the Cassandra project, like my two priorities coming into this are how do we keep Cassandra fast and how do we not knock it over, right? Like we don't want to add a feature into here that's going to impact non-CDC enabled writes, that's going to impact the stability of the system, that's going to expose us to other kind of risks in that way. So that's kind of where the one of the axes of compromise was how do we make something useful and usable that also doesn't like blow everything up in our face. So yeah, it was kind of painful to go back in the ticket and to have to beat my head against the wall while Brian right next to me beat his head against the wall. And like there's just a bunch of different people on the ticket. They're like, I really want this stuff. And the answer is maybe someday, but right now we got to go through baby steps to get this stuff out without breaking everything. So approach number naive, as I like to call it. That was, why not do it on the coordinator, right? Don't bother with replicas, just log it on the coordinator, keep stuff in memory, punt out clients when they ask for it, rejoice, everybody goes home. And that immediately started up all these questions of, okay, what about edge cases? What happens when that coordinator dies? Well, you just lost all that CDC data. And you have data in commit logs on replicas that's no longer accounted for. So how do you reconcile that? And it's like, okay, this smells. That's not good. What happens when this node dies? When the log gets corrupted? What does it do to the heap? So it started to ask all these questions of, if we're going this route inside the Cassandra node proper, inside that JVM, does it feel safe? Does it smell right? And pretty much the answer collectively was no. This is something that we couldn't find a way elegantly to get that all to work without exposing ourselves to something that we just considered untenable, ultimately. And that led to this. That led to us going through all these different designs, all these different ideas for it, trying to rank, okay, how bad is this on the Cassandra complexity? Because we have to maintain this code down the road, right? Everything's going to be coupled with that, and changes to the system are going to have that implication. How hard is this for users on their implementation complexity, right? What are users going to have to do to be able to use this feature? Is it fleshed out? What's the GC pressure look like? Write perf impact? How good of a feature set is it? And one of the things that kind of stuck in my craw was that like using a CQL table for this would basically have given us conveniently all of the replication, the reconciliation, the correctness, and it also would have been bar none the worst performing option we could have gone with. And using CQL tables for orthogonal features, like say hints, for instance, it has given us some ideas about what not to do. So that's kind of where like, no, we're not going to go that route. So basically, 6 and 7, that whole issue was how do we get this thing to not have a race where we end up with disjoint data, because I'm not going to write a repair mechanism for commit log flags. That's just not going to happen. So basically, we kind of hit the point with design number 8 where we're like, okay, what if we use the commit log segment as the CDC log of record? We have one write, we have one fsync. We have code in the code base that can read that, so we can flush that out and expose it. And it kind of felt a little elegant. And then there ended up being problems with that 7 days before release, obviously. So we're down to release number 9, or idea number 9 rather, which I'll go into more detail a little bit later. But it's still kind of that fundamental quote unquote epiphany of use the commit log segment as the CDC log of record. But we're going to interleave CDC and non-CDC data and then have like a post-processing brain. But all that's out of the Cassandra like proper scope. So yes, there's complexity to it, but it should, in theory, be a more modular, bounded complexity issue that we don't have to necessarily struggle with. So kind of what I'm talking about, like one of the things that we found here, and one of the things that I've kind of been advocating for and pushing for, is having more like upfront design review process and more collaborative review, which with a fully distributed remote open source community is kind of hard. Like a lot of times we do this async on Jira and like there's long delays between things and you totally have zero context with what you're writing. And so like 90% of what people write comes across as assholes. And it's like, it's really painful and difficult sometimes. Yeah. So, so we kind of went for more of a collaborative design approach. I tried to get a bunch of different people involved, like get a bunch of different perspectives. And that's how we reached that point of, you know what, this is starting to sound like what we want out of a CDC log of record. It's starting to sound a hell of a lot like a commit log segment. Why not just use it, right? And that came from that kind of iterative process. And the awkward question, the elephant in the room, is how is this really different than the commit log archive? Which, when you go to discard log, you just move it to it begs that question. And the difference is really kind of the behind-the-scenes infrastructure features that are now going to be available in Cassandra to flag specific data as being of interest to you. And also, so just to be more specific about that, you can alter a table and say with CDC equals true. That flags the tables containing CDC data, and then when mutations are open to a commit log segment, it'll be toggled to represent, hey, this commit log segment has CDC data in it. So that's kind of the internal implementation, is how we figure out, when I go to discard a commit log segment, do I care about it or not still? A big change, and this doesn't seem like a big change, was to reject allocations on a commit log segment when we're at a certain size threshold. But like right now, Cassandra is super all about your writes getting into the system and allocations that were failing. So going into the code is basically like, I felt like an elephant in a china shop. Like it's like, okay, well, we're just going to change this one thing and watch everything break. It's like, okay, so now we need to figure out how many different undocumented like invariants in the code do we have where people basically assume that allocations will always succeed. There's some multi-threaded thread signaling things happening there, etc. So that was a lot bigger than I expected. Tracking the flush and unflush size on disk sounds pretty simple. Turns out it's not. Because when people consume these CDC logs and delete them off disk, we don't have a mechanism to notify Cassandra. And if we did, that'd be putting a bunch of complexity in Cassandra or using JMX or something equally terrible. So that process, we don't want to block allocation. So there's these issues of we don't want to impact the write path, so we can't synchronously check the size of files on disk because that's a linearly unbounded problem of growth and performance, which incidentally is faster on Windows than Linux, which is, yeah, there's sadness. So anyway, and then last but not least, the commit log replayer contained all of our code for reading commit log segments. There really wasn't any kind of exposed interface for what does it look like to read a commit log segment on disk. And so this ticket refactors all that out. So we have a commit log reader, we have a commit log read handler, and in theory, and in practice actually, because Carl's actually put together kind of a test implementation of this, it's relatively simple now for a user linking against the Cassandra code base to actually read commit log files on disk. So life lessons from this, know what your values are, know what everybody's values are in the process of the conversation, so you can try to hit a target that's as close to kind of the collective value system as possible. Be clear about the use cases, hard requirements, know what your architecture doesn't want you to do. And yeah, it's hard to remain fast the more stuff you put into the primary critical path problem. And the last life lesson that I took from this is it took a hell of a lot of design revisions to get to something where we all collectively agree this is great, and it took up until, again, a week from release to say, wait a minute, there's a problem still, which we'll get to that. So.
Hey, Josh, just on your last point there, I think it was really good that we went through the 7, like you actually had them all there, so we could actually see.
They're in a design doc.
Right.
Yes.
And I think that really helps everybody get to the how do we iterate this as a group. That was really good. That was
my theory. That's what I was hoping. So it's So that's another thing. Typically, if you want to understand what a ticket looks like, you got to go to Jira and then read the novel of Doom. This ticket actually has a design doc attached to it, and on page 2 is basically the TLDR updated. Here's where this thing is right now. And if you read through that as a developer, as a user, and you say, why in the hell did you do this stupid thing? That's when you go to the Jira ticket and you search for why we came to the conclusion we came to. All right, so another thing that I pushed for on this one, I saw another ticket where with flush and post flush, we went in to make a change and somebody reverted it and bit it and said, hey, when you're working on commit log code, it probably helps to have multiple reviewers because this is very delicate code. I didn't want to have my commit reverted, so I said, okay, the commit log replayer that I'm refactoring, Brandon wrote that thing, did a big chunk of that multi-threaded commit log segment manager was involved in. Let's get Brandon as a second pair of eyes on this as well, just to make sure. That proved to be a huge boom because in this kind of a context, there was some interdependencies between commit log replay and having a single commit log segment stream that basically made our multiple commit log segment stream idea more risky than it would seem at face value. And him having worked inside that code deeply, it was more readily apparent to him as opposed to me kind of coming into this not having that intimate expertise with it. So is there a pointy button? I'm not pretty good. We had two separate commit log segment streams with no post-processing is the original idea. So CDC data goes into one segment stream, non-CDC data goes into another. And that way consumers and everybody else has what they want right there. We don't have to iterate over the same data again. We don't have to reread the segments, etc. The problems with that are probably many. We bound where we're going to replay data from in the segment stream. We have this idea of a replay position that I'm now renaming against randomers. So there's this question of like, what happens if you write CDC data and then you disable CDC? It's going to have data written into one stream and then data written into another stream at the same time. So then you have data for one table that's in two different commit log segment files. And what happens if you have non-CDC data that keeps getting written and that all gets flushed out? Well, now you end up with this kind of a nebulous lack of clarity as to where do things stand with which data is where at what time. And I started going down that rabbit hole of, you know what, we could say every time you change CDC data that you have to, or every time you change the CDC flag, we have to flush all data for that table. But then you start getting down into that kind of, that rabbit hole of trying to enforce like the atomicity of state between the schema and the data that's in the commit log segment so you don't end up with races. And that just started to smell. So much like some of the earlier discussions about the design and having two separate files, it's like, while we can make this work, the question is becoming readily apparent, should we? So that's where I said, you know, well, let's back off this and try to figure out, and Brandon had a suggestion about a design that was basically like number 6 off the chart, but using the segment manager anyway, it's all contained. So that again led to get another refinement of how do we make this thing correct and not blow things up. Again, messing with the commit log, fun times. So I kind of consider that I'm considering recommending that for any major ticket, we have 2 reviewers on the thing. We've had discussions about that, some of us on the project, and it seems like it's probably not a bad idea for large tickets. So here's kind of an overview of what the design looks like for what a CDC pathway looks like from a Cassandra node down to clients. The top half I have is like our in-tree Cassandra implementation, and the bottom half is like what a client could potentially write to this. So right now, V1 is basically this top half. The Cassandra node will put commit log segments that have CDC data in them into this CDC raw directory. And that data will basically live there. If you hit capacity, I think it's 4 gigs by default, you will start getting write timeout exceptions for writes that are CDC enabled because you no longer have space to accommodate those writes. And the way that we determine that is because the segments as they're allocated will have a forbidden flag for them, so CDC won't be allowed in. V2, and this is already something that, again, Carl has started work on this for purposes of testing out the V1, is writing that commit log reader and a compactor that'll basically, you can configure it, say, here's all the tables I care about. It'll read the data from CDC raw, and for any mutation that's on one of those tables you care about, it compacts it into CDC process. So at that point, basically, on all your replicas in your cluster, you're going to have commit log segment files on disk with data you're interested in. And obviously, there's still a delta between that point and you like having a web front end that's visualizing data live from the back end of Cassandra. And what that could theoretically look like would be, you know, extend the CDC compactor a little bit to actually parse the data and kick it out of a socket. Like you can basically, hopefully at this point, play around with getting your data live into another system much more rapidly than before, which that's kind of the point of our V1 implementation. Minimize impact to Cassandra and start to just kind of slowly extend the feature set of what we have available on this axis here. So the design doc, like I said on the ticket, is up to date. I think I tweeted yesterday. The TLDR of V1 and V2 is right here. I've talked about pretty much all the things on here, but this gives you kind of a digestible reference for what does this thing actually look like. And your V1, your V2. There are some basically limitations to the way that we're doing this, and basically only really 2, and one of them I don't really consider. But anyway, repair and interim CDC mutation loss. The idea here is if you have a node that goes down and you make a bunch of changes to the same piece of data on a node, there's going to be CDC records on that node for all the things that went through. But when we repair, we don't send across every single delta that ever happened to something. So all of those interim mutations on that same partition key won't necessarily show up when you bring back up the dead node and repair it to it. This, ultimately, what this comes down to is this idea that if you want quorum consistency with CDC data, then use quorum consistency on it. Right. Like that's kind of, understand that when we repair, we can't necessarily restore the interim state of things that happen. And you know, if you want it on all of them, CL all. If you only want it on one, CL one. It's not that different than kind of your current expectations of what the availability of that data is, with the one caveat that there isn't necessarily eventual consistency on all nodes for their CDC records on disk. Yeah, that pretty much sums up what's on that slide. And then last but not least, I put it in quotation marks. Well, you can see that it might be considered a compromise, that this data is going to be available in mutation format, which means you have to be serialized mutations, which means at this point, like the only implementation that's conveniently available is the commit log reader and mutations in the Cassandra code base. The alternative here would be for us to have some kind of centralized abstraction that we use to kind of bridge the mutation format with whatever format we would define. And the problem with that is, again, that's more work on the critical path. And maybe I'm being a little too hard line about it, but I would like to think that people would want their CDC data to be written as close to as fast as regular data as possible. And then maybe pay a little bit of a price on post-processing separately. But that way, the rest of their data in the cluster is not negatively impacted by this process. So that's where we stand on that front. And open source means patches, so if you do it, feel free. So further reading, there's your ticket, there's a design doc attached to it, and I probably way over time, so any questions we can cover tomorrow.
Quick question.
Yeah.
No.
Wait, what if like CDC online is like it's a Microsoft SQL 2008?
Change data capture.
Data capture. Like, what does it do?
Just
Why would I want
Wikipedia change data capture. It's like a database.
Yeah, I'm reading it, but it just sounds like a bunch of marketing. Like,
Do you want to run ETL every 24 hours, or do you want to get your data within 500 milliseconds?
Are we writing it in there in Microsoft?
In general, because all sorts of tools have like ETL tools.
Okay, while we're talking about this, let's get Robert Stoop up to speak next. We're going to push